the last episode, Mauricio and Emily drew Zara's square fabric and wrote an equation using the formula length times width. They represented the area of Zara's square by the letter X. In this episode, they will rewrite their equation using 2 variables rather than 3.
Now, there's something really special about a square. What is it?
It's unknown.
About this square?
Well, about any square versus what we might call a rectangle. What's the difference?
They gotta be the same side.
What do you mean?
Like, if this is, like, for example, I'm gonna erase it right now. If the length is 6 inches, the rest gotta be 6 inches, or else it's gonna, like,
It's not a
Do
square line.
you agree with that?
Mm-hmm.
So right now you have 3 variables, L, W, and X.
yeah.
So what that means is that to find an area, you're telling me I've got to give you 2 numbers. I've got to give you the value of the L and the value of the W in order for you to find the area. So I'd have to say like, the length is 6 and the width is 6.
Yeah. So we could just do L times width. Huh?
Yeah.
You could? Okay. So that area is sort of, what's the area then?
What that equals?
Yeah.
Okay. Yep, you're absolutely right. Is it possible for you to use just L or just W with the...
Oh, yeah.
Well, why?
Like with the exponent.
How?
Look, since you know how we said that if to order to be a square it has to be by the same number, so it could just be L squared or W squared.
What do you think, Emily? Is that possible?
Yeah, I think so.
A square is special because each side has the same length. That means that to find the area, you only need to know the length or the width, not both. So rather than use 3 variables, Mauricio and Emily wrote an expression for the area just using L. They remembered they could use an exponent to express a variable times itself. So they wrote L squared. Next, they will illustrate this idea with a specific amount, where the length is 6 inches.
Let's say that Zara's fabric is 4 inches on each side. Can you make a drawing that shows the length, width, and area of Zara's square?
Diagonal square. Go to the right. Right, more. Little bit more, little bit more. Right there, right there. And that's 16 inches. Right.
I was gonna do.
So tell me about that.
That's like the same as 4 squared. It's gonna equal 16.
And 16 is the area, and the 4 inches is a length and a width.
Nice. And if you were going to draw in the 16, how would you do it? And what does each of those, what does that represent?
16 inches squared, like
Okay. And what's an inch squared here?
like
one little square.
one little square.
Now, do you want to try another one with a specific number, or do you think you're ready to try to do it in general? All I've told you is the how much one side measures. Could you write a formula for the area?
Yeah.
Okay, try it.
Um,
Draw a picture and write a formula. So all I'm going to give you is like how much one side measures, how many inches it is. Let's say I have a number in mind, but I'm not going to tell you what it is. Could you represent it with a letter?
Yeah. A.
X.
X. This one or this one?
X.
Are you ready?
X1.
Just put X. And then parentheses.
Okay, can you label anything else?
B.
B.
A, B, C.
Y. Make it Y.
Y?
So are you telling me that I need to give you two numbers in order for you to find the area?
No.
No.
Oh, because if you use the two variables, it means you're telling me I need to give you two numbers.
Oh no. Wrong. There.
Because those were the same.
Yeah.
Oh, say that again, Emily.
The X on like this X and this one, they're the same because it's a square, so there's no need to use another variable.
Yeah. And that's gonna equal.
It's gonna equal what?
The A.
Ah, the A. And what are the units with the A?
Inches squared.
Okay. Now can you write a formula for the area?
X squared equals A.
X
Squared.
times X equals A.
And so that's one way to write it. And
Yeah.
Emily, you had another way that you like to write it? What do you think about these equations we have here? So the equation for the area of a square, you could write as x times x equals a, or x squared equals a. How does that compare with the very first equation you guys came up with of the a equals L times W?
Oh, okay. It compares because we use length and width, so basically it was width and then length, but we only had to use one.
Is that agreeing?
Yeah.
How would you say it?
Because at first we were thinking of it as like a rectangle where where the sides aren't all equal, and we were using two variables and only one was needed.
Yeah. So you made it. It's not that it was wrong. It's just that this is much simpler now. You can see that you only need one number that I need to give you in order to get the area.
Do you see why they didn't need a third variable? As Emily put it, the x inches and the x inches are the same because it's a square. They saw this in their example too, where 4 inches was equal to 4 inches. This is different than in their previous work with rectangles, where the sides weren't all equal. So, to find the area of Zara's square, they knew they could use a simpler equation of x squared is a inches squared. In the next episode, they'll think about increasing the length and width of Zara's square by specific amounts.